And
Testing, testing.
hello. I hope you all enjoy your lunch, and let's move to next talk. Our next speaker is Lucas Meneghel Rodrigues. He works at Red Hat for quite some time. He works in automation and testing in virtualization. He's the author of Autotest, Test Framework, and Avocado, which we will be talking right now.
Hey guys, thanks for being here. I'm glad you guys are here. My name is Lucas, and I work for Red Hat in test automation, and I'm here to talk about test automation, and that is not quite surprising, right? And also, we will share with you some visions we have about test automation, and let's then get started. This presentation is structured in a way where we will discuss, in the first part we will discuss a little bit about how we go about developing test tools, how we go about developing test automation software. Then we will present Avocado, which is this new project we're working on, and that we hope that will bring some extra value to the test automation field. We will briefly talk about some basic concepts behind Avocado development, and then we will go straight to a demo. So, about testing tools, we have this dilemma. When you are in the software industry, chances are that you have to test software. So everybody has to do it. But traditionally, we have these two groups, QE and development, and they usually have different attributions, and they often have some conflicting views on how the testing process works. For QE, testing is the central part of the job, so that's in your job description. You have to do testing. So this means that when you are approaching testing, you have to put on some processes and metrics necessary for you to at least evaluate how you're doing things. That doesn't hold true for development. Development has other focus in the process. And one of the problems with developing these test tools is that the test frameworks or the test tools, they're often developed from the QE perspective. So they are taking into account having a lot of reporting, a lot of metrics that you are going to use to see how effective you are at doing testing. But this usually makes those test frameworks too hard to approach. They have a steep learning curve. And usually the developers end up kind of bored and they start doing their own thing. This test framework looks nice, but it's too professional. I'm going to write my own Perl script, and that is it. This picture summarizes what we have with QE versus development, this conflicts that we have. QE is interested in crash and burn the program. If we can't do that, we're not doing our job. And we're very, very, very concerned about that. Development is more concerned about developing tools. So we have those tools and they are useful. We want to write better tools and keep improving the tooling that we have available. It's sort of, we're reaching the same goal, which is deliver quality software, but we have different focus. So I just mentioned that often the developers just look at the test frameworks and say, hey, this looks nice, but I don't really have the time or the resources to learn it, so I'm going to just do my own shell script or Perl script or whatever. And that's certainly not optimal. We want developers to be involved in the testing process. We want QE to be giving development useful tools, and the developers should be able to use these tools. So how do we do it? How do we reconcile these differences? And we thought about that a lot in the previous year, and in fact, like the past 5 years, I've been on a constant struggle to get the developers of my team to use the tools that we have been developing. Our tools are awesome, have a lot of features, but they're often too complicated for these developers to use. So we thought about it, and we went about this by radically simplifying things. Only expose the developers with a small subtest of the tools that we have available, and make the testing tools to be just another auxiliary of the development process, just as it would do with Valgrind, GDB, Git. And whatever tests you develop using this system should transition to a larger test grid or a larger continuous integration infrastructure in a seamless way. That is why we started developing Avocado. Avocado, we thought about it, and we wanted, we first started branding it as a new testing framework, but testing framework implies a lot of complexity, so we were going with something simpler. It's a testing toolbox. It's really the same thing. Anyway, but we developed it on the premise that testing should be fun, testing should be simple. You shouldn't need to download large Git repos and do a lot of setup, and after like 5 days, you hopefully be able to run a test. We want something better and simpler. You start with this powerful but simple test runner that has some optional features that will be helpful for you to do your test development and do your main application development and debugging. You as you need it, as QE needs it, we will add more building blocks and add more features to the process, but you only have to expose the developers to this very small subset of the tools. As for writing tests, we don't really need to restrict test development choices. You don't have to force a language in particular. You could use any language you want, although you would get some extra benefits from using proper test APIs. And this same test runner that you will be running in your laptop can be just used in the continuous integration infrastructure. So it's something modular and scalable. When we were developing Avocado, so these were the guiding principles when we were developing the testing toolbox. It has to be test agnostic, so use whatever language you want. You don't need to use a test runner. You can also, Avocado, besides being a test runner and some other tools, you also have a testing API. You have extra API that you can use to get some extra features and some extra tooling in your testing. And all this is scalable and progressive, so you try with this to deliver both simplicity and power. So why would you use Avocado then? Different from these other testing tools we've been working before, you can just go and do yum install Avocado in your Fedora box, and it's right there. You can use it. So it's easy to deploy and use. You have some, and you have some instrumentation that you can do in your test. Frequently, when you're trying to reproduce a problem, you ask the user, so I need the output of, for example, uname minus A, so you know the kernel version, GCC minus V, so you know what is the version of the compiler you're using, and so on and so forth. And Avocado does that all automatically. It goes and collects system information. So you give to the user some extra tooling and some extra information that you don't have to capture by yourself. And also you have standardized log collection and generation. You have these APIs, if you do choose to use the APIs, where to write the logs, and the logs will be there, and it's all predictable. It's good for the user. This is a little diagram, because we like diagrams, to show the Avocado architecture. Here's our happy user, because Avocado is awesome, so he's using Avocado, and he develops the test. He uses the Avocado test runner, and the test results will be delivered to the user through our output plugins. We will talk a little bit more about plugins later. But the person can see at the test results through the terminal or our HTML report. And other users, which are machines, can use other machine-readable outputs, such as JSON, XUnit, planned to deliver TAP as well. And the Avocado runner can also use these useful tools such as GDB and profilers to instrument the test, and so you know what's going on inside the test. So I work in the virtualization team, so you're interested frequently in testing QEMU. So you spawn QEMU and you do a lot of operations with a virtual machine, and you want to know what happened inside QEMU, the system calls it made and stuff like that. And Avocado is able to use those tools to instrument and see what's going on. And now it's demo time. So Avocado is a standard Unix tool. So you can see here you have help usage. You have man page, which is something that we're still trying to deliver in auto test due to some design decisions that we made. So we have this nice man page that you can take a look at and see the basic commands and have a quick overview of how to use it. So you got the man page. You can use the help, which is the same you get here. If you try some subcommands, you can get help on those subcommands. So this is pretty standard features, but it's kind of a new thing for us that we're thinking about this usability aspect from the beginning. We were not really super concerned about usability in the very beginning when we started writing these tools. So let's try to run an Avocado test. So you see the first feature of Avocado here is that tests are really, any executables inside your machine can be used as tests as long as they do return 0 if the test passed or different than 0 if it failed. So you can really just use bin true or bin false as your test and it will work just fine. So this is one of the features with Avocado. With our previous test frameworks, we asked the user to do something extra, and that's frequently unnecessary because you're just trying to run that simple C program that you wrote, for example. So let's say you want to debug this test and see what Avocado is spitting on the job log. You see here there is a job log. It's a text file with the job results. There's another HTML results that we provide to the user by default. Let's see what happens if I do this show job log thing. So here you see Avocado is spitting out what it would spit here. Usually, of course, for the user, it's better to have this output, but sometimes you just want to debug things, and you can use show job log to just show this text file. Now, let's try to run a more advanced test that's not so advanced. And now I'm going to throw the option Open Browser. Open Browser will just open the HTML report for you. And then you get the HTML report. You can see what happened here. You can see the debug logs and links to the results directory. Another concept that you can see here in Avocado is that we have a job ID, which is a SHA-1, similar to Git. The idea with this is that you can run tests anywhere and upload to a central database, and then you get unique job results for each one of those test runs. What else? You also, in this HTML report, you get some system information that Avocado collected for you. You can see information about your system, the kernel version, CPU info, and other extra information that we collect by default for you, and you can configure that if you are feeling like. So yeah, you can see here that Avocado, you can run tests by passing a path to a test, but we also have this little feature called aliases. So if you have an Avocado test directory configured, I can just refer to the test to this, by their shorter names, such as pass test and skip test. It will do the exact same thing but now only pass test and skip test. Avocado resolves it. It searches in the test directory that is configured and executes it. It's really the same thing. Avocado can also scan a directory recursively and execute the tests that are there, such as, so I can just pass the tests directory, and it detects all the tests in there and starts looping through the tests. Of course, this takes too long, so I'm just going to interrupt it. And you see Avocado behaves well here and just finishes the job run. So let's say I made a typo, and Avocado will tell me, so yeah, no, you cannot run that because this doesn't resolve to any tests that I know. It's not a path, and it's not something inside the test directory. So what if you're not a human being? If you are another script, what would you do? Usually we have this bad habit of making programs scraping human readable results, and that is very bad in many ways. I can't even begin to tell you about that. So what would you do? You can simply use one of our output plugins. You can pass XUnit, and then Avocado, instead of spitting a human readable output, it would just spit a XUnit output, which is compatible with Jenkins. We thought a lot about the existing testing tools, and Jenkins is very popular, so we decided one of the first output plugins we implemented was XUnit. So you have the pass test being executed here, and then it spits out an XML that you can just integrate with Jenkins or other scripts that do parse that. Okay, so I was talking about the simple tests, the arbitrary executables that you can run in your machine. But I was also talking about APIs. So you can use some test APIs and do a little more. You can get a little more bang for your buck. And this is what an Avocado more instrumented test looks like. One of our first versions is the Python API. Here you just import some Avocado libraries, and it's very similar to a unit test. We were modeling many of the Avocado aspects, the user experience after unit tests. And we even have the little trick that makes tests to be executable by themselves. You basically implement an action. You see there are some facilities here, such as self-log, that you use to log messages in different levels of different importance levels. The test doesn't do much. It actually just sleeps for a second or whatever number of seconds you choose. Of course, you can use the Avocado runner to run that, but you don't really need to do that. So if you just use the Avocado libraries, you can execute this as a standalone test. So that is it. You get the standard output of the test. You get the proper return code. Everything behaves nicely. Frequently, when you're executing a C program that you're writing that you want to test in Avocado, you frequently want to instrument it and have other tools to interact with it to get some additional reports. So we're going to use a bunch of our wrappers. So this is the wrapper feature of Avocado. So let's say you have this test we call data_dir. What the test does is it compiles a C program. I'm also going to show you the C program, which is just a hello world type of thing. It builds that program using one of our APIs, the build API that you can use to build your software. Then it goes to the directory where the binary is built, executes it using another API that we call process.run, and log the result. And also we have a cleanup routine here that just deletes the directory. So you see here, if any test needs additional data to function properly, you just provide it as source file.data. So this is our very, very simple C program that we have here just for the sake of the demonstration. So we want to run this using perf. So Avocado. Oh, yeah. And before that, I should show you the wrapper itself. So it basically calls perf record with appropriate options, and then it outputs to the Avocado test log there. And yeah, that's basically what it does. So what I'm doing here, I will run data_dir with the perf wrapper, and whenever we call data_dir, we use the comma here, the column here, and we provide data_dir. So we're saying to Avocado, so whenever you call this program ending in data_dir, you execute perf.sh. And that is it. So it's a simple way to provide that information to Avocado. You execute it, and then you can take a look at you can see here a perf.data binary file generated by perf. So we can pick that up and run perf report. And you can see a nice perf report out of the execution. Of course, you can customize this to whatever you want. This is just a simple example on how you would do it. Okay, now say you want to use GDB to debug one test and then take a look at the backtrace of what's going on. So once again, we're going to use the Avocado data dir example. I'm going to clear that up. Space what? What should I do here? I'm sorry, it was a mistake here. Okay, so it didn't build the data dir because of a permission problem. I'm going to try another one. Yeah, there's some permission problem with my directory that I was not anticipating. Oh, yeah. There is a bug with the RPM, and I was not anticipating that. I was making the demo using my source code copy. So yeah, there you go. Okay, so it's not very easy to read here, but anyway, this test is now stopped because a debugger breakpoint was reached. When you don't provide the main breakpoint, it stops in the beginning of the main function. So the Avocado provides you this script that you can use to fall into GDB, debugging the binary directly. You can do things like doing a backtrace. You can here see what's going on here, see the backtraces. But I should have, disconnected before if I wanted to execute, to finish executing. So I'm going to. can go here again. If you disconnect here, you can see that Avocado will finish the debugging session and successful and end the test. Another feature that you're usually interested in is the running tests on a VM. So let's say here, right now I have no open VMs here, but let me start with Manager. So I have this Fedora 2020 libvirt domain. I can run tests on this libvirt domain by using the VM plugin. Okay, so I'm going to execute if you take a look here, Avocado will start the Fedora 20 domain for you, initialize it, and then execute the test for you. So there you go. What happened here is that Avocado executed the test, pass test and fail test inside the VM. The VM already has Avocado previously installed in it, and it gives you this result back. You can see that my host is 3.18, and if you check the you can see that Avocado just ran the test on 3.13. It's the Fedora 20 domain. Another use case where we want to cover is that you have one test and you want to execute it in different environments, or you want to pass different parameters to it. We came up with this thing we call the multiplexer. It's based in YAML, so you have a YAML file that describes many different ways that you can use to execute a particular test. So this is one of the examples. So we have this example test, sync test, that takes two parameters, loop and length, and you want to combine to pass both to the test, and so you have a total of 9 combinations between different values of loop and different values of length. We have this multiplex command that allows you to debug your multiplexing file. You can take a look at the tree structure of the file, and you can take a look at all the combinations generated by this file. You can see that there are 9 variants generated by combining all those testing scenarios. And then you can run the sync test and pass the multiplex file to this test. So Avocado is going to execute those 9 different combinations and pass the different parameters to the test. This is very common in virtualization tests because you have to cover different operating systems that run on the guest, different options that QEMU was called with, and other things like that. If you take a look at the job log, you will see that Avocado correctly passed the length and the loop parameters to each one of the tests, and everything went just fine here. We also developed a new Vert-based plugin, but since yeah, I will not be able to demo that, but let's then go to the other commands that we have in Avocado. So let's say you want to list the tests available to Avocado in the test directory. So this goes into the test directory and lists all the tests for you. You can use it to list the tests available in any directory. Like I said, just a simple executable is a simple test. An Avocado instrumented test uses the Avocado Python APIs. So for example, I can see if there are any things that I can use as tests on the temp directory. So it will give you this information about the files that are there. So you have these files that could be used as tests here. And you could even attempt to run the tests in there. You can use the -v option in the list command to show the tests that Avocado doesn't consider them as tests. You can also list the configuration available. So Avocado has this concept of configuration files. You can use you can edit values there and then change the behavior of the Avocado test runner. If you want to check the directory is being used by Avocado, you can use the data-dir flag. So I was mentioning about the since I'm running from the source code directory, it's picking both settings and tests from the source code directory. And also when it outputs data and job logs, it shows you also that information. So I think I have less than 5 minutes, so probably I should end the presentation. So the resources we have here, we have our Avocado main website. So this is the Avocado website. You can go there. We have the resources. You can look at the project on GitHub. There's read the docs documentation as well. We have a Trello planning board that we use for our sprints. We develop Avocado in a sort of a Scrum-like approach. So you can take a look at what we have, what we are working on. So this is the read the docs documentation. We try to be very thorough and explain everything available there for you. Avocado runs Travis CI, so we do test our code as you would expect. And also we have a Copper repo that has Avocado RPMs that you can just go there and install. Obviously there are some little bugs here and there, and we will work the best we can to fix them. Another thing that I have to tell you that I would like to tell you is that feel free to attend the Avocado workshop. Lukasz, one of our teammates, is going to present it. And yeah, it's just my recommendation to you guys. All right, so that is it. I think now is the time for the questions. The question is, can Avocado run tests in parallel? We do not have a run in parallel feature right now, but we have it in our planning board, and we are going to add it soon enough, I think. What else?
Can Avocado run tests distributed?
Distributed, you mean in other machines? Oh, cluster-like tests. We do not have, the question was, can Avocado run distributed tests? So tests in nodes of a cluster. So the answer is you could use the remote plugin, which is very similar to the virt plugin, only that you are running with arbitrary remote systems instead of actual libvirt VMs. So you could use that. Although we do not have any cluster-specific information. But in terms of distributed as a generic remote machine, yes, Avocado can run them on generic remote hosts. What else?
Why is it named Avocado?
Because I thought it was a fancy name. That is it. Nothing special. And I like avocado, but so does most people, so.
How much is it portable to Avocado run on Windows?
We are not concerned with Windows portability yet. It could be something, if there's enough demand for that, we can think about it, but we don't test on Windows, and we're not particularly concerned in making sure that it works on Windows. But yeah, it's certainly a possibility.
So is it meant for upstream developers or only for maintenance?
No, it's meant for upstream developers.
I think it's hard to convince upstream to use Avocado if it runs only on one supported platform. It's not portable as the upstream code.
But yeah, I understand your point, but usually we're mostly concerned with testing Linux and developing programs on Linux. So Windows support was not something that, not a lot of people asked for it. But yeah, certainly if you add extra platforms, you draw more developers to it, and it's certainly something to consider. Sure. Pre-set up. Yep. No, just an SSH connection and install the Avocado RPM in there. You are all set. Yeah. I'm not sure if that's what we want to have some complete solution to just create VMs and stuff. It's something to consider, but right now we're just trying to keep it simple. The user is expected to have Avocado deployed in the systems, and also we have the provisioning systems that do that. We probably do not need to implement that sort of functionality, in my opinion. We're out of time, so thanks a lot.